All right, let's figure out the derivatives of the natural log. Remember, yesterday we were kind of doing e's and exponentials. So remember, logs and exponentials are inverses of each other. So this is in logarithmic form, log of a, log a to the x equals y. In exponential form, that's a to the y equals x. So let's figure out what the derivative of the natural log is. We'll be doing a lot more with natural logs than LOGs. So remember, u is some function of x. So if y equals the natural log of u, I think we can agree if we put that in exponential form, then e to the y, because the base is e, is equal to u. Well, let's do what we know how to do. Take implicit, use implicit to take the derivative of that. As we learned yesterday, the derivative of e to the y would be e to the y, so copy, times the derivative of the exponent. And remember, if we're taking the derivative with respect to x, then the derivative of y would be dy dx is equal to, now I'm going to write this a little kind of weirdly because remember, u is some function of x. So with that being said, I'm going to write u prime, and that's of course du over dx, the derivative of u with respect to x. Because again, we're taking the derivative with respect to x. So u prime is du dx. Well, then dy dx is going to be u prime over e to the y. But what did we say e to the y was? Well, dang, e to the y is u, and I get dy dx is equal to u prime over u. So the derivative of the natural log of something, you do u prime over u. So very simply, it says find the derivative of natural log of x. Well, gosh, that's going to be, my u is x, the derivative of x is, x is x, and the derivative of x is 1. So the derivative of ln of x is 1 over x. What about this? So what about this? Oh, shoot, they put absolute values in there. So let's look at the absolute value. As we've talked about before, you cannot take the derivative of an absolute value. So what do we have to do? We have to write this function, and we have to consider, well, what if x is already positive? Okay. And then what if x is negative? Now notice I don't put 0 because remember you can't take the log of 0. So that's why I don't have an equal to on that piecewise function. Well, if x is already positive, so if x is already positive, then I would just have the equation natural log of x. Now let's look, if x is negative, what would that absolute value do? Wouldn't that change the sign? Remember how we copied the equation, and if we change the sign of what was in the absolute value? Well, let's look at the derivative now. Now that I've rewritten it as a piecewise function, what will my derivatives be? Well, natural log of x, that's one we just did over there. I'd have x here and I'd have 1 there, so I'd get 1 over x. Now, what if I ask you the derivative of the natural log of negative x? Well, my u is negative x. What's the derivative of negative x is negative 1. Well, sweet. Well, a negative divided by a negative, this ends up being 1 over x as well. So what does that mean? What does that do for us? It means for once, if you see an absolute value, you do not have to worry about it. You don't have to rewrite as a piecewise function. I did it once for you to see that it didn't matter. So here's the cool thing. If you have an absolute value around your argument and you're asked to take the derivative of it, you can totally ignore it. The absolute value, okay? when taking the derivative of a natural log. So that's awesome for you. Whether it has absolute values or not, you don't worry about it. What you memorize is when you are asked the derivative of the natural log of something, you have in your head u prime over u. Friends, watch how quick and easy this is. Differentiate y equals the natural log of u. Think of that as u. In your brain, you go, oh, u prime over u. I actually do the bottom first. I just copy my u right here, and then I look at that bottom and say, what's the derivative of that? And I take it, and I write it up there, and that problem is finished. Love it. Does trig bother me? Nope. Not if I've memorized my trig derivatives, it hasn't. Do these absolute values bother me? Nope. Because for once, when I'm taking the derivative of the natural log, if I see absolute values, I literally ignore them. I just change them to parentheses. Nothing but a thing. So, u prime over u. My u is sine of x. What is the derivative of sine? Is cosine of x. Now they'd probably go a step further, of course, and they'd say dy dx is cotangent. With trig, they usually simplify. Now let's do, obviously it gets a little harder, okay, but we're going to be smart about it. It says differentiate this thing. Now be careful when you rewrite this. I want everybody to rewrite what you think that y equals is. That's the natural log of x to the 1/2 power. Let's be very clear that this and this are not saying the same thing. Okay? Those two things, because in this one, the 1/2 is only going to the x, and of course, in the problem that we're doing, the 1/2 is doing all natural log of x. So how do we do this? What's the power rule? But within the power rule, of course, I have to remember the chain rule. So remember what you should say in your head when you're doing a power. Power to the front, decrease the power by 1, but don't stop there, multiply by the inner derivative. Now what's the derivative of ln of x? Well, hopefully you got that memorized and you say, oh, that's just 1 over x. Now let me clean that up because they probably would. So dy dx, the only thing that's on top is a 1. I would have 2x, I'll just multiply in any order I want, and they'd probably write it that way, and that would be my derivative. Now I do kind of want to look at this one over here, so I would write that down. What if I wanted the derivative of that guy? You're like, okay, my u is x to the 1/2. I'd have to take the derivative of that, put it on top. Friends, sweet, sweet friends, let's remember log properties, shall we? Do you agree? So if I want to take the derivative, let's say I want to do this one. Do you remember the log property that says I can move that 1/2 to the front? So this would be the same thing as this. That makes it so much easier. If you can make your argument easier because you know you're going to have to take the derivative of it, then do that. Well, that's a piece of cake because the derivative, it's like, remember when you have a constant, he just kind of comes along for the ride. I'd have the 1/2, the derivative of ln of x is 1 over x, so my derivative is 1 over 2x. That's super fast. Much faster than putting that on bottom, taking the derivative and putting it on top and having to simplify. You would get the same answer, but oh gosh, log properties are going to make your life easier. Now let's look at the next problem because it leads us right into that. In the same way, look at this next problem. Well, first of all, the absolute value, just who cares? I'll make that a parentheses. I'm not even let that bother me. But at this point, you're like, oh my gosh. If I let that be my u, when I had to take the derivative of that u, the u prime would be quotient rule with a square root. Oh my gosh, that's difficult. Then make your life simpler. Rewrite y using your log properties. Remember, if you have an argument that's divided, I can write that as the natural log of x minus 1, and I think you're okay with me doing 2 steps in one. I would have the natural log of x minus 2 to the 1/2 power, but just like I just did, I'm not going to put that 1/2 there. I'm going to put that 1/2 there. Now taking the derivative, let's take the derivative. dy dx, just do them individually. The natural log of x minus 1, that's my u, so x minus 1. The derivative on top, so the derivative of x minus 1 is 1, minus, I'll put my fraction. Now the 1/2 is going to come along for the ride, so I'll just put the 2 there. My u is x minus 2. And then what's the derivative of x minus 2? Well, that's also 1. Even if they have the answer with a common denominator, that's much easier than doing the other route. So I'm just going to use this, and I am going to think about what my common denominator would be. I think you would agree that this guy would need a 2 times x minus 2. And if I multiply that on bottom, I'll have to multiply it on top. This guy would need an x minus 1. So I'd have to multiply him by an x minus 1 on top. So what do I have? My numerator, I'll go ahead and distribute. 2x minus 4. Now be careful, I have a minus parentheses x minus 1. So I'm going to go minus x plus 1. Okay. Over 2 times x minus 1 times x minus 2. Are we all in agreement with that right there? And what do I finally end up with? I'll have dy over dx. If I cleaned all that up, 2x minus x is x. Negative 4 plus 1 is minus 3 over 2 times x minus 1, x minus 2. Much, much faster than doing it the other way. So log properties are your friend. So I want you to try number 6, and I will tell you this. I want you to do number 6. Sometimes they stop right here. They don't even get the common denominator. I wanted to show you one where they did, in case you had to do that. But when you do number 6, let's say the answer choices were not with a common denominator. They stopped it there. So you stop the video, try number 6, and then come back. All right, my first step, I'm going to start over here because it's going to be a long equation here. I'm going to use my log properties. So I'm going to have a string of 3 different logs. Natural log of x plus 2 natural log of x squared plus 1 minus 1/2 natural log of 2x cubed minus 1. So hopefully you understood all those log properties. Now I'm just going to take the derivative of everything. So dy dx, natural log of x is the easy one, 1 plus x. Here, 2 comes along for the ride. I put x squared plus 1 on bottom. I have to multiply by the derivative of the bottom, so my u prime, that would be 2x. Likewise here, this 2 comes along, and I would have 2x cubed minus 1. The derivative of 2x cubed minus 1 would be 6x squared. And let me just clean all that up. Okay, so thank you for not making me get a common denominator. I would have 1 over x plus 4x over x squared plus 1. Here, that would just be a 3. So minus 3x squared over 2x cubed minus 1, and yay, they didn't get a common denominator, and I'm done. So be smart about your logs. If it helps you to use a log property first, then you need to do that. And lastly, I just put this guy in because, once again, you got to remember all of your other rules. You got to remember product rule, quotient rule, chain rule, trig. I just can put more, different things. So let's get after it. Hopefully, when you see this, you see a product. So you say first times the derivative of the second. The derivative of the second, natural log of 2x, that would be my u. U prime is actually 2. I know that cancels. I'll clean it up in the next step. Plus the second, natural log of 2x, times the derivative of the first. How do I take the derivative of e to the 3x? Remember, I copy, times the derivative of the exponent, so that's 3e to the 3x. Yes, that cancels to just be 1. So my dy dx, again, you'd have to look at the answer choices if it was on multiple choice, but I could write it as e to the 3x over x plus, nothing, I don't know why I'm putting the e to the 3x first. I guess I just felt like it. So I would have that. Obviously, could they do a factoring step? Yes, they could do that. Could they get a common denominator and put it all over x and slap an x on top? Yes. So that's why I'm saying you have to look at your answer choices when it comes to how they're going to write the final answer, because I could write that final answer many, many different ways. So just use your answer choices or the answers that are on your worksheet to know kind of how far you have to go. And that's the derivative of natural log. Every time you see the derivative of natural log, your brain should say u prime over u. U prime over u. Which, that helps us to know the formulas, to understand the formulas, and it makes your life very, very quick when you have those formulas memorized. All right, peace out.